Okay, let's go ahead and move into section 9.5, which is variation. And it's a little bit of a change of all these rational expressions, even though you'll notice that we do deal with one rational expression type down here. But pretty much this kind of goes off in a different direction. So we have three different types of variation: direct variation, joint variation, inverse variation, and then actually I guess there is a fourth one, which is combination of all of these, meaning we could be doing direct, joint, and inverse all in one um, equation. So what does this mean? So this means that we have at least with direct and with inverse, we have one or two variables. And you'll notice in here we have y and x. So I have my y variable, my x variable, my y variable, my x variable. For joint variation, I have y, x, and z. And then I have this thing called k. K is what is known as my constant. So it is a value that we need to calculate, and it means exactly what it says there. It's a constant, so it stays the same. So if we calculate a k value for a specific problem, it's going to be that value for that entire problem. Now, that doesn't mean the k doesn't change for different problems, but it does for different problems. But it stays the same for that particular problem. So this is the kind of the definition. You'll notice that direct variation just means that y and x, you'll notice they're across the equal sign, but as x increases, y increases. So as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. Doesn't really matter much about what the k value is. And then joint variation just means that instead of just having two variables, the y and the x, notice we have a third variable that we've introduced. And so y depends on what's happening with x and z. So if x is going up and z is going down, y is kind of staying the same depending on how much they're going up and going down. If both are going up, then y is going to go up faster, and so on. Inverse variation just says that we have this type of relationship. Our constant is always on top in the numerator on all of three of these. But in this case, you'll notice our variable is in the denominator. And so as x increases, that means this fraction is getting smaller, which means that y is decreasing. So when we say inverse variation, that means as x goes up, y goes down. As x goes down, y goes up. Okay. So let's take an example in direct variation. Here's a specific example from your homework. If x varies directly as y, find x. Now, whenever they say x varies, then that means x equals. So we say x equals k times y in this particular case. And it says find x when y is 8. Well, all the information they're giving me is y is equal to 8. So I know what y is equal to, but I don't know what k is equal to, and I'm trying to find x. So what I have to do first is I have to find k. Now, we're always going to be given some extra problem or some extra points here to try to find k. So that means I'm going to plug them in. So notice that my equation is this one here. And so it says x equals -4. So -4 equals k times 10, because y is 10. And then we solve for k, so we divide both sides by 10. Of course, when I do that, those cancel. So k equals 2/5. Okay, remember that I like to leave things as fractions. That's 0.4. But I prefer to leave it as a fraction when I'm doing all my multiplication. It's just easier to deal with the numbers. And if you want to convert it later, you can do that. Okay, so then our next step is to find x. So now it says find x when y is equal to 8. So we have our equation, x equals k, 2/5 y. There's my new equation, or my real equation. And now we know that we want to find x when y is equal to 8. So we're going to set y equal to 8 now in this case, which is 16/5. Okay, and that would be our answer. Now, if you want to write it out as a decimal, we could do that. That is 3.2. So I would prefer to leave it as 16/5. 3.2 works as well. Okay, next problem. If y varies directly as x, here we go with another one, but this time it's y equals kx, and y equals 35 when x is equal to 7. So 35 equals k times 7. We divide both sides by 7. So those cancel. That becomes 5. So my k value is equal to 5. Now it says find y when x is equal to 11. So that would be 55. That would be my answer. So that's all we're doing when we're plugging those in. Pretty straightforward overall. And we'll get to the rest of the problems in the next video.